my dear visitors and subscribers, very nice to meet you here again at Crazy Engines channel. I saw a very interesting adjustable laboratory power supplies on AliExpress called Nice Power SPS 3010 2KD. Wow, it's not easy to pronounce. What attracted me really, it's very reasonable price, less than 200 bucks. It's compact design. And most importantly, it's independent dual channel construction with parallel and serial operation capabilities. In other words, I've got two independent regulated power supplies and stabilized power supplies in one box. I wanted to test it with you, verify it, and of course draw some conclusions. I don't want to spend your time for typical unboxing procedures. Everything is so typical. Device supplies in general carton box, insulation foam papers, AC power cord, and the pair of output load line wires. Power supplies looks very cool. Nice black matte powder coating. I should say that it's not heavy. It's not heavy. I'm sure that it utilized contemporary high-frequency PWM conversion technology. So we will learn about it later. This power supply doesn't have input AC voltage selector, usually mounted on the back side. So you have to choose your input voltage during purchasing. Mine is 220 volts AC. So let's power it. It's online now. Front panel equipped by few adjustment knobs, and it looks like an encoders. So it doesn't have rotation limits. It may be not quite familiar at the first glance, but I've got used it very quickly. So here we have two groups of encoders. Each group independently controls each channel, voltage and current setting. This DC power supply can work in two main modes: DC voltage supply, constant voltage, and it's indicated by the red lid here, and so-called constant current mode, where device is keeping pre-adjustment current when the load varies. Each mode is indicated by lead indicators. So here and in constant current, it's will light here. Device automatically switching from one mode to another depends on the load and adjustments. Device also equipped with one USB-A port. Additional and very useful feature, DC channel commutation. You can choose three modes of operation. The first mode, it's independent mode. Each channel works independent according to its setting. This is the terminals for two channels. Serial mode, where the channels are connected internally in series. For example, we can switch it by button SER. Yes, you can see. It's switched. For example, I need 50 volts output with a 4 amperes current limit. So we're pressing serial top and adjusting requesting voltage and current. And a current accordingly. The third mode, the parallel mode, where channels are internally connected in parallel, so you can get increased output current in comparison with the independent mode like that. We pressed power. Both channels are connected parallel. Important that the serial or parallel modes output load lines should be connected here to these terminals, parallel serial terminals. So let's check the accuracy of the device voltmeter readings. I connect almost two multimeters. So far the inaccuracy of the readings does not exist a few millivolts, which is really good. I think that it worth to check the voltage stability under load. We will load each channel with 1 ohm 100 watt resistor to check the voltage stability. Supplying 8 volts to 1 ohm load resistance should give us approximately 8 amperes of the current. But you can see the current is less than 8 amperes, and this is practically due to the fact that this resistor is made from nickel chrome alloy. So being heated, it will increase its resistance and the current will be reduced. So we have right now the 50 watts and 6.2 ampere load. Let us check once again the changes of on the output terminals. This is without load. This is with load. Also checking voltage sag on the second channel. The same conditions: 1 ohm resistance, 8 volts output. So as you can see, the voltage drop is very small, so approximately 200 millivolts, which is approximately 1.5–2% of a drop. So the purity of the supplied power is also quite important. We can check it with a digital oscilloscope with the same load of 7 amperes. The white noise, so it's noise without any load, it's not connected to the supplies, it's the 120 millivolts, and right now I'm connecting power supply to the load. So we have 272, 280 millivolts, 280 millivolts. If we remember the white noise, so the noise before connecting, it was 128 millivolts, we can easily state that we have low noise under load is less than 200 millivolts. With the different frequencies, it depends, you can see it depends on the load. So from 140 till 200 kilohertz. So in this chapter we will dive into the power supply internals. As you can see, it's utilizing contemporary electronic design and microcomputer controlled DC power supply with the HF PWM conversion technology. So the traditional iron core power transformer replaced by high frequency PWM transformer. Due to this HF conversion technology, it's much smaller and lighter than traditional iron core power supply transformer. So here we can see two main absolutely identical power supply boards. Here is interconnect board, which is responsible for switching to the serial or to parallel mode. And here is the microcomputer control board, which operate with the digital displays and with the encoders. So, my dear viewers and subscribers, let's summarize what we have found. First, what's good? It's compact, lightweight, in 2-channel independent regulated DC power supply. It supplies mostly stable voltage and hold load current normally. It has an incredible low price on AliExpress. Second, what could be better? First of all, output voltage stability could be increased. The second, high frequency noise is quite noticeable. It could be a little bit quieter. The fan noise, the separate factor. Under sufficient load, two fans turns on and their noise is quite annoying. If you are in a trench under artillery fire, you might not notice it. But if you are in the lab, the noise can be annoying. So, my dear viewers and subscribers, of course, it will be very interesting to know your opinion about this device. Thank you a lot for watching. See you very soon at Crazy Engine channel. I wish you a very nice day. Thank you. Bye.